Right, no lads. So what we're going on to now is this idea of independent events. So this is what's called the AND law. So the probability of A and B, if you remember from the last video, it was the probability of A or B. Okay, so the probability of A and B is equal to the probability of A, and means multiply by the probability of B. Okay, so it's a lot simpler. Okay, and it does tend to help a lot with bigger subsets where you've got lots of combinations of things, probabilities that can come out, and you can usually get there quicker because we're using multiplication rather than addition. Okay, so it's easier for me to do it just by just trying a few of these with you and just see how you get on. So let's try this one. Okay, we'll use cards because I think cards are the best thing to use. So 52 in a pack, usual, no jokers, the usual type of stuff. Okay, so we have 52 in a pack. We pick one and replace. That's the important thing there. We're replacing, so there'll always be 52. Pick one, look at it, replace. Okay, and then we pick a second one. So this is very important because we're setting up the idea here that if you pick one and you don't replace, it affects the second one because it's reducing the total possible outcomes because you're not replacing it. So we're picking one, looking at it, putting it back in, picking a second one, looking at it, putting it back in. And we're going to try and work out some kind of rules about what happens when we're trying to guess what cards are coming out. So the first thing we're going to figure out is the probability both are black. Okay, then we're going to figure out the probability both are kings. And finally, we're going to figure out the probability the first is black and the second is a king. No, we'll go king. And the second is a diamond. Bigger chance. Diamond. Right. So there's our scenario. Okay. So let's have a look at it then. Go to green. So let's work out the probability that one card is black. Okay. So the probability of one card is black. Probability of a black card is 1 and 2. We know this. So the probability of black followed by black is going to be probability of 1 and black. So multiply those probabilities together. You have a 1 in 4 chance of picking a black card followed by another black card. For those you're into your gambling. Now let's have a look at the second option. Both are kings. So we want king and another king. Again, they're independent. So we want king and another king. So we want the probability of what's first of all, let's work out the probability of a king. Okay, the probability of a king is 1 in 13. It's 4 out of 52 is 1 in 13. So the probability of king and king is going to be 1 over 13 multiplied by 1 over 13, which is a staggering 1 over 169. 13 squared is 169. So it's quite... I was betting on king followed by king. You know, there's not good odds there. Okay, and now the third one. The probability of a black followed by a diamond. So black and diamond is what we're looking here. So the probability of a black is 1 in... What is it? Sorry. What to say? Was it first? Is the... I think I was... Yeah. Let's go with a black queen. Make it harder. Black queen. So there's 4 black queens. So that's... let me think. 4 black queens. So there's 4... Oh, it's 2 black queens. Yeah, and there's 2 black queens. 2 black queens. So that's 2 out of 52 or 1 in 26. Okay. And then second one is diamond. Okay. So how many diamonds do we have? We have 13 out of 52, which is a quarter of them are diamonds, isn't it? So what's that? 4 20s are 80 and 4 6s are 24. So that's 104. That's a bit better than the last one. So you can see what we're doing. We're just constructing it using multiplications. Okay, we'll try a different one. We'll try one that's a bit maybe tougher than that one. Right, let's find another one for you to try. Right, right, here we go. A dice is drawn 3 times. Okay, and we want the probability of no 6s in any of the 3. Okay, no 6s. We also want the probability of at least 1 6. And then here's an interesting one. Exactly 1 6. Okay, so we're gonna tease this out a bit. Okay, so this one's a little bit more complicated, for want of a better word, because again we're getting into the nitty-gritty of the mechanics of the arguments. So there are 6 numbers on a die, so the probability of getting a 6 is 1 out of 6, which means the probability of not getting a 6 is 5 out of 6. So the probability of no 6 followed by a no 6 and another no 6, bad way of kind of putting it, is going to be 5 over 6 multiplied by 5 over 6 multiplied by 5 over 6. 3 5s, 5 5s, 25. That's 125 over 6 6 is 36. 6 36, 216. That doesn't cancel down. So that's the probability of, in other words, rolling die 3 times and none of them are 6s. So it's actually close to 50%. It's close enough. I'm just trying to contextualize it. Right. At least 1 6. Okay. Well, that's the probability of no 6s. So the probability of at least 1 6 is just the probability of 1 minus the probability of no 6s, isn't it? Just using logic. So that's the probability of 1 minus 125 over 216. Okay, calculator for this one. $91 over 216. Okay. At least one. Could have 2 or 3, but at least one. Now, third one. This one's a bit tougher. Exactly 1 6. Okay. Now, this one we're just going to have to think about for a second. So, there's 3 scenarios here, isn't there? Okay. So we could have the probability of a 6 followed by a no 6 followed by a no 6. And then that'd be one possible outcome. The second possible outcome could be no 6, 6, no 6. And then the third possible outcome could be no 6, no 6, 6. Okay, so let's work out one of these anyway, just for starts. So the probability of a 6 is 1 in 6 by a 5 over 6 by a 5 over 6. So that's 3, that's still 216, and we've got 25 over 216. Okay, so that's one of them, right? Then we've got our second one, probability of a no followed by a 6 followed by a no. And then the third one, the probability of a no followed by another no 6 followed by a 6 on your last one. So they're all going to give you the same thing. So they're all going to give you 25 over 216. But here's the kicker. Okay, we don't know which one of these turns up. So the probability we're actually looking for is this or this, or this. And the important word there is or. And or, of course, means you add them. You add the three probabilities. Now, we've multiplied them to get them because they're independent, but we're adding them because we don't know which one of them is going to be it. So adding these up, that's just going to be 75 over 216. What the hell is that? 75 over 216. 75 over 216. Will that divide by 3? 3 into 75 goes 25. 3 into 216. It goes 72. So when I add them, 25 over 216, or this combination, or this combination, is actually 25 over 72 when you cancel it down. So that's the chances of it happening, which is really cool. Okay, so that's another example of it. Okay, hope that helps.